All right, so we're here with our Period 6 class to do our last lesson for the entire semester, which is very exciting. We're almost there. So, for this lesson, there's going to be two small lectures. All right, the first one's going to be very short. I want to first talk to you about the letter I. Do you guys remember from solving quadratics when we had that letter I that we had to use sometimes?
Negative, the square root was negative.
Exactly. Well, square root can't be negative, but the number inside would have a negative number. So this is what I had you guys focus on when we did the quadratic formula. And if you got a negative number inside the square root, you knew that all you had to do was put an I out front, and then you can deal with it as a positive number. All right? So I, by itself, is the square root of negative 1. Okay? This is going to help you guys for the SAT as well when they have questions on this. So the letter I, I'm sorry, Sergeant? Excellent. The letter I is the same as the square root of the negative 1.
Could it be like any number? Or
No, that's what I means. So let me do another example that I think will help your brain, Daniel. Yes, Camilla? Well, let me do a different number than negative 1 and show you what I mean. What if it was the square root of negative 9? Not I9, it's I times the square root of 9. But what is the square root of 9? 3. So this actually would be written as 3I. Good question, Camilla. Camilla asks, like, the order, does it matter? No, I would accept, like, if you wrote I3, Camilla, I would accept I3. But just kind of like we don't write X3, we write 3X. Same idea, you should write 3I. This is the one I want you to focus on. All right, now, that's only talking about imaginary numbers, that letter I. What mathematicians do sometimes, though, is they use real numbers and imaginary numbers together. Okay? Think back to when we solved quadratics. I'll take your question 1 second, Nicholas. Remember we had like an answer that was the 3 plus or minus I times the square root of 7 over 8? Something like that? Yes. Right, that was an answer? All right. It's okay if you don't remember this from solving with the quadratic formula, but we have a real part and we have an imaginary part. When you have a real and an imaginary part, it's called a complex number. All right, and that's what we're going to spend the majority of today talking about, is complex numbers. Okay, Nicholas. This slide. Say it again.
Does it have to become negative? Like negative?
Are you talking about the letter I?
Yeah, when you put the number.
Yes, so you should only be using this I if you have a square root of a negative number. So if we're taking the square root of a positive number, Nicholas, we won't have the letter I. Thing.
why does it say I squared?
So we're going to use I squared when we do complex number operations. So if I have I squared, that would be the square root of negative 1 times the square root of negative 1. Right, so there's two of them. All right, what's negative 1 times negative 1? Positive 1. So I squared, okay, when we do that, it's going to be, put them together, you get I squared is the same as negative 1. Like this. Yeah, so like, let me do it this way. Let's do the square root of 2 times the square root of 2. Whenever you have two of them, it's just going to be the number inside without the radical.
No matter if it's negative or positive.
Doesn't matter if it's negative or positive. So if it had been the square root of b times b, both of these are b inside, it would just be a b without the radical.
So negative 2 is negative square root of negative 2 times square root of negative 2.
Is negative 2. Yeah, is negative 2. Okay. Yeah, you're good. Don't worry about that. Don't worry about that. You're okay. Now, there's one more thing I didn't want to talk about before we get to doing an example. And it should be right here, called the complex conjugates. Okay? Now, a complex number is always in the form a plus bi. And this a is going to be any real number, so like negative 2, positive 6. Any real number here, can be a decimal too, it's fine. And you see this letter I means there's going to be an imaginary number. Okay? Now, when we get into our next unit in January of 2020, when we come back from break, we're going to be talking about solving quartic polynomials. That's x to the 4th power. Okay? So we're going to have 4 roots. Now, with quadratics, our roots were either 2 real roots, right, like this. Let me show you. Right? Remember when they cross the x-axis? So that's 2 real roots. Or we have 2 imaginary roots. You see how that one doesn't cross the x-axis? So that would have 2 imaginary roots. So whenever we do the quartic polynomials, you're going to have a combination of real ones and complex ones. All right, so there's going to be some real and some imaginary. And with conjugates, if I tell you that a plus bi is a root for a polynomial, a minus bi is also a root for that same polynomial. Those are called conjugates. And the reason you need to know that is it's going to help us divide polynomials. All right? Okay, let's try to do a few. Okay. Example 1. Find the complex conjugate for 8 plus 5i. All right, so what I tell students is, what's the real number part here? What's the real, no, the real number part is the 8. The real number is always going to go first. So you're going to rewrite that, guys. Rewrite it. So rewrite the number, whatever it is, 8, negative 8, whatever the number is. So rewrite it. Now, what's the imaginary part here? 5i is the imaginary part. What's the sign in front of it? Addition. So to get the conjugate, you do the opposite, which would be subtraction. So the conjugate is 8 minus 5i. Okay, so let that sink in for a few seconds. I'm going to call on someone randomly to do the next one, B. So take a look at B. I'm going to call on someone. Shh. I'm going to call on someone. Shh. That's it. It just wants the conjugate. It just wants the conjugate. Shh. Not the opposite, right? The conjugate. It's different. Just wait. Yes, the first number doesn't switch. Let's do the next one. I'm going to call on Pearl. Pearl, what is the conjugate for negative 3 plus 2i? Negative 3. You got it. Well done, Pearl. Now, the reason I wanted to go over that one is because a lot of students think that the negative 3 should change as well. The only thing should change should be the imaginary part. Victoria H. Yes, Dominic? We're not even there yet, right? All we're doing is just conjugates. Everybody understand how to get a conjugate for a complex number? You just change what part, Fernando? Just the imaginary piece. You don't change the real number. Okay, let's look at adding and subtracting. So let's start slow here. Dominic, you wanted to ask about division. We'll get there. Let's first look at adding. All right? Look at this problem. This says 4 plus 2i plus negative 6 minus 7i. The reason this is going to be simple for you is because it's just adding like terms. What is 4 plus negative 6? No, maybe it's not going to be easy. Negative 2. 4 plus negative 6. They're different signs. So you subtract them, keep the sign of the bigger one. But you should have noticed there, Sebastian, not the fact that you got the number wrong, is that which ones did I add? I added the real numbers, right? I added only the real numbers. Now I'm going to add the imaginary numbers. Please start using imaginary. What's 2i plus negative 7i?
Negative 5.
Very good, Dominic. And we're done. Camilla. Is it asking for a conjugate? It's not asking for a conjugate. It just says add these two complex numbers together. I put subtraction because 2i plus negative 7i, they're different signs, Nicholas. You have to take the sign of the bigger one when you subtract them. And 7 is bigger than 2. Good question. That is the answer, Marina, yes. Carlos? 2i plus, yes, minus negative, no, not minus negative 7. 2i minus 7i is negative 5.
Could you write it as negative 2 plus negative 5i?
You would be wrong. You could, it would be wrong. It's not asking for a conjugate. It just says to add them.
You said that you make it opposite.
Never said that. All I said was when you find the conjugates, you make the imaginary part opposite. We are not finding conjugates in these problems.
Okay.
Come on.
My bad.
You're fine. Yeah, what's up? Yeah, okay, so, sorry, Camilla. Camilla wants to give us the answer for the second one, which is subtraction. So be careful, Camilla. What's 5 minus negative 2? Excellent, Camilla. Most students put 3 there. Well done. And then negative 2i minus negative 3i. Wow, very good, Camilla. Sebastian? If you put 1i, totally fine. You're exactly right, Camilla. No one writes 1x, so we're not going to write 1i. You could write it, it wouldn't be wrong, but we just write the I. What, Sebastian?
Why don't you write one I? It makes more sense because.
Go for it.
But it wouldn't be wrong.
No. But do you write 1x?
But that's.
Okay. Any questions on adding or subtracting or conjugates? I know, Daniel, we messed your brain up for a few seconds there about conjugates. Are you good on the difference between these two things? I didn't. That's not what I said.
Only one eye. The answer is one eye.
No, the answer is 7 plus I. Camilla said, could you write 1i here? I said, that's fine. And we had just like a quick aside for why we don't write 1i. But Nicholas, if you want to write 1i, that's fine. 5 minus negative 2 is 7. Yes, because subtracting a negative is actually addition. Right, remember those yellow things in the back are calculators if you need them for help. Any other questions? All right, so you're about to stand up to try these 8s. Try these